Kia ora koutou katoa, it's Mrs. Goodson here. This video is about Lewis diagrams. So Lewis diagrams show the valence electrons for atoms and molecules. Now it's the valence electrons are on the outside of an atom and they are the ones involved in bonding and they can move between atoms in chemical reactions. So the valence electrons are really important. They're the ones we're interested in. So we want to be able to draw Lewis diagrams for molecules with up to 4 regions of charge around the central atom. So I'm going to show you all about Lewis diagrams. Just to note that Lewis diagrams can also be called Lewis dot diagrams or Lewis structures. That's all the same thing. Okay, so just slightly different names crop up. First of all, for atoms, Lewis diagrams for atoms show the valence electrons. Now we tend to put them in pairs where we can. So we've got nitrogen is in group 15. So there it has 5 valence electrons, and so we just draw them as dots. So this is an example of a Lewis diagram for nitrogen. So you need to be able to work out, use the periodic table to work out which group an atom is in, and therefore how many valence electrons it is. So each dot is an electron. So here are the groups. So we've got group 1, just in Roman numerals, group 2, group 3, also known, these ones also known 13, 14, 15, 16, 17, 18, all right, depending on if you use the version that the more modern version has the transition metal numbers in it. So everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. So as long as you can use the periodic table to work out the group. So for example, oxygen is in group 6, group 16. So it has 6 valence electrons, okay? When atoms are covalently bonded, that means they're going to share electrons. For example, in carbon dioxide, it's a molecular substance, CO2. In order to get a full shell, oxygen, which we just saw, had 6 valence electrons. So in this diagram, the 6 valence electrons are shown with a cross. And then carbon has 4 valence electrons, which are shown by these red dots. And so if you look here, oxygen has access to its full 8 electrons, so it gets stability, but it's sharing some electrons with carbon. And in fact, each pair of shared electrons is a bond. So this is double bonds in this one here. Okay. Water also is a molecule that shares electrons. In this case, oxygen, it's got 6 valence electrons. Hydrogen, remember, it's only got 1. So that's that one there. And this hydrogen provides 1. Now, hydrogen and helium are small molecules, so they only need 2 valence 2 electrons to have a full shell. Okay. Molecule, this is why oxygen is O2, because each one has 6 valence electrons, but they share 2 each, and so that's got a double bond there, each valence electron bonding happening there. So the oxygen gas, O2, can be drawn like this. So we get rid of the circles and then we can just use the dots. Okay, so where we had the bonds here, we can either draw them as dots or we can draw them as a dash. So in this next slide, you can see that there is a bond between the hydrogen and the chlorine atom, and we've drawn it as a dash. Now these electrons here are called non-bonding electrons or lone pairs. Okay, they're really important. They also the valence electrons, so that chlorine has a full set of 8, because this line here is representing 2 dots. Okay, one, can I draw dots? There we go. Okay, so if you see a dash, that actually means 2 electrons is a bonding pair. So most atoms, apart from hydrogen, helium, also we're going to see an exception of boron and beryllium, but all the other atoms want to have 8. Okay, so that's the octet rule, where each atom aims to have 4 pairs or 8 electrons around each atom to complete its valence shell. So this is how we're going to work out the Lewis diagram for ammonia. We're going to work out the total number of valence electrons. So ammonia is made up of 1 nitrogen and 3 hydrogens. So it has a total of 8 valence electrons for all of its atoms. So we want each atom to have access to 8 valence electrons, or in hydrogen only 2. Okay, so 8 for nitrogen, 2 for each hydrogen. There are 3 hydrogens, so that's a total of 14. So we need 14, but we've only got 8. So they're going to have to share them. So take the difference between 14 and 8. They need to share 6 electrons. So we divide that into pairs. Pairs is 3 divided by 2, we get 3 bonds. Okay, so we can draw the diagram here. We can either use dots. This one uses dots. And these are the bonding electrons. So these ones here, these 6 electrons that we just worked out that we need to share, are the ones here. Okay, they are our bonds. So we can draw them as a dash if we need to. And this version of the Lewis diagram, which both are correct, by the way, you can use dots or you can use dashes. This one just very clearly shows the bonding electrons, and then we've got one lone pair. All right, so these hydrogens all have access to 2 electrons, and this nitrogen has a full octet 8. So it is, we say it's satisfied. So this is a video just that you can look at just for ammonia. This is another example. This is chlorine. Chlorine, Cl2, so all the halides form, so halides are group 17. And so we've got chlorine, so these are the bonding electrons between the atoms. Okay, so Cl, we could draw it like this. And these non-bonding electrons, now students often forget to put in the non-bonding electrons, but they're really important because chlorine has to have a full octet. It's got to have 8, access to 8. Each atom has a full octet. So just draw the dots, put the dots in the non-bond, always remember the non-bonding electrons. Okay, so there's another video for you to look about chlorine. You can look about water. Water has 2 sets of bonding pairs, all right? So altogether, water has 1, 2, 3, 4 areas of electron density or electron charge around it. 2 are bonding and two non-bonding pairs, okay? Oxygen gas. To make sure that each oxygen atom gets 8 electrons, it's going to share like this. Okay, so it's going to share these 4 electrons. So each bonding pair can be shown by a dash. It's got a double bond between it. Okay. You can also get a triple bond. So nitrogen has to share, this represents 6 electrons, 2, 4, 6, 3 pairs. Okay, that's another video you can watch just about nitrogen. Now, beryllium and boron are quite small atoms, so they don't need octets. So you've got to be careful with beryllium. And so this represents 2 electrons, 1, 2 there, and 2 there. So this beryllium has not got a full octet, it's only got 4. And this boron has 2 there, 2 there, 2 there, I should say 2 there. So it got access to 6. So they don't follow the octet rule, so they are exceptions. So just beryllium and boron. So hydrogen, helium are 2, and then beryllium and boron don't need a full octet. So there's a couple of videos for you to watch about those ones. This is an example just explaining about multiple covalent bonds. We've got double bonds. So double bonds are extra strong covalent bonds because it's sharing 4 electrons. Each line represents 2 electrons. And you have triple bonds. Nitrogen has got this triple bond, which is 6 electrons. There's a couple of videos about oxygen and nitrogen. And just a reminder to remember the non-bonding electrons. These are also called lone pairs, okay? And so the non-bonding electrons are shown just around the outside of an atom. Chlorine has got 3 non-bonding pairs, or 6 non-bonding electrons. So this video has been about drawing Lewis diagrams for molecules with up to 4 regions of charge around the central atom.